this one.
Hey, I'm Thomas Maurer. I'm here with Craig and Vinicius, and we are going to talk about containers today.
Yes, we are.
Yep.
Perfect, awesome. So can we have a quick look at what containers are and why we should actually care about Windows containers?
Yeah, absolutely. Craig, you want to?
Sure. So, containers are really a technology for packaging and deploying applications. So a lot of customers have existing Windows Server applications and services that they want to deploy into all these different environments. And when you think about the pain points that come around with having to deploy code, you want your environment to be configured exactly the way that you wrote the code, right? And so containers are a technology so that you can take your code with its dependencies and its configurations and then package it up. And once you have that container package, you can deploy it into another coworker's machine, into the cloud, into your on-prem data center. Really, you have a lot of plenty of flexibility. So containers are about portability and flexibility. So yeah.
Yeah, okay, that sounds awesome. So basically what you're saying, I can pack my application in a very small container, and I basically use that and move it from different machines on my laptop where I developed that application, and move that to in a server or something running in the cloud, like AKS?
Yeah, really, any recent version, as long as you're deploying that container to a host that is running a recent version of Windows. So starting with Windows Server 2016 and later, we introduced containers. And so in Azure particularly, there are several services that we offer that support Windows containers in preview or in production quality, like AKS or Azure Container Instances as well, too.
Okay, that's awesome. So do we want to have a quick look at that, or can you show us something about that?
I'm going to actually pass it on.
Yeah, sure. So let's kick the laptop over here. Let's get started.
Okay.
All right. So on the left here, we've got a terminal that is just open on the host, and then on the right, it's also on the host right now. I'm going to use a tool called Docker throughout this time to interact with these containers. Just understand that Docker is a tool for managing, building, creating, starting, and stopping these container images.
Okay.
And so I'm going to do this command called Docker images to get the list of container images I could start on this machine. And I'm going to pick this this one right here.
Yeah. So these are basically templates, if you will, something like that, like images I can reuse all and over again. Is that what you're saying?
That's correct. Yeah. While Craig types the command to spin up a new container, brief explanation on what container images are. So just like in a VM, you spin up the VM and then you put an ISO to install the operating system. With containers, what you do is you get a prepared or prepackaged container image that already has all the configuration for the operating system or even the framework that you are going to use, like .NET, any other framework that you can think about. But anyway, so what Microsoft does is we provide the server core and nano server container images, nano server being for new born in the cloud kind of applications, and the server core more focused on app compat, so applications that you have already and you are containerizing.
Okay, awesome. So we have different container images, which we give as base container images. So you said one is focusing more on modern applications, .NET Core.
Correct.
Why would I use the one or the other? Is one is there some benefits to using one or the other, in size?
So in terms of size, the nano server container image is 100 megs, so it's really small for a Windows image. But really, in order to get that, we reduced a lot of the APIs and the services in the platform, so you really have to target your application from the development side to nano server in order for the application to run. Server core is a little bit larger. We are today in 1.5 gigs, but it gives you the ability to get applications that you have today that are not containerized and move into containers.
Okay, so wow.
Yeah, so I think a key thing that is good for customers to know is .NET Framework-based applications should be running in Server Core.
Yep.
Server Core supports .NET Framework. If you want to target .NET Core apps, though, Nano Server is going to be your ticket there.
Okay, that sounds great. I mean, I remember when first Windows Server Core came out, this image, I think it was huge. It was really big. And then now we come down to 1.5 gig in that. Wow.
And we continue to improve that, so we'll see even smaller images over the time.
Okay, that's awesome.
I think we're down to 1.1 gigs, and we started at 3.5 gigs compressed.
Wow. Wow.
So quite a progress, and we're going to keep on driving that.
Okay. So perfect. Let's have a look.
Yeah. Okay. So the terminal on the left is just a PowerShell instance that's opened on my host machine here. And the terminal on the right is actually inside of a container instance. It's a Windows Server Core. And so what we can do, we have PowerShell open as well in the container. We can poke around in it. And one of the first things I want to show you is one of the properties of containers is that they have file system isolation from the host. So if we were to go into the users directory and take a look at the users that are on this container, you have this here. Now, if I was to go do the same thing on the host, you're going to see a different list of container users. You have Vini AP over here, whereas you have container administrator and container user. And so these containers are running on the same machine, and yet they get a different view of the file system. That's very neat. Yeah. And so actually, we didn't get a touch on yet what's actually happening under the covers with containers. So containers share the underlying kernel of a Windows operating system. And we like to think about the kernel as this executive entity and service that normal apps when they run in Windows they don't have unrestricted access to the hardware. That's not good. We don't want an app to just be able to read memory anywhere. So when it goes and it requests for memory to do something in its app, it's making that request to the kernel. And so containers share that kernel, but then boot up an entirely new user mode up top. So they have this new instance of Windows user mode running. But still running on the same machine. So right here, file system isolation. Now the second thing that's pretty cool is process isolation. So if we were to do a get process inside the container, what's the guess as to how many processes are running in here?
Remember that Windows run like
a lot of processes.
A lot.
22, I think.
Okay.
And let's do it on the host. Boom, right there. Wow. You can already see, like, geez, it's just many more. And then we can actually measure this. So we have 112 running on the host. And when we do the same thing inside the container, 23.
Oh, wow.
23.
Okay. Right, so that is how small and light those things actually are, right? Yep. They're reduced to that. And they're completely isolated. So from the container, I obviously cannot see what's going on the host, right? Is that
correct?
Okay.
Right. But then the interesting thing to point out is that the host is an all-knowing entity, and so it can see what the container is doing. So the way to illustrate this actually is if we do a get process, and we search for this process that runs in every single user mode Windows called SMSS, we see one instance. And yet when we do the same thing on the host, you are going to find 2 instances. And the reason for that is because the host can see inside the container.
Okay, so the host really is the master who can say if I see multiple applications there or multiple containers, I would obviously see all these processes running in those containers, and I could take action on these as well if I want to, if I have some tool. But that sounds it's very optimized. So like it's very less overhead in compared to a virtual machine, right? Where you had that virtual hardware. On top, you installed a operating system with everything, again, like totally redundant to what you already have. And now with a container, you just let go of that, right? Is that what it is?
Yeah. In fact, if you think about from an ops perspective, one of the things you have to take care about for virtual machines is you have another operating system that you have to back up, you have to update, you have to do all the regular operations, right? For containers, in fact, you have one operating system in multiple instances of your application running isolated from each other inside of each of the containers, but you don't have another operating system in the container that you have to take care and back up and update and all those regular operations.
Okay, that sounds great.
One interesting thing that Criag showed is that you can, from the host, see the processes inside of the container. Some people will look at that and think, well, that is not exactly very secure from a multi-tenancy environment. So one of the things that we have in the Windows platform is the Hypervisor. Hyper-V is well known by the audience. One of the things you can do with containers is you have another mode to run containers called the Hypervisor isolated mode, where we wrap the container with the hypervisor as a virtual machine. In that case, even the host can't see what's going on inside of the virtual machine, so it's really isolated from the hypervisor, more secure in another way for you to run your containers on top of Windows.
Okay, yeah, that makes a lot of sense. There was just one thing I want to ask. Like, this sounds like I can do too much from the host, but with Hyper-V containers, it seems to be fine and protected, and we get that extra layer of isolation.
That's correct. From a enterprise perspective, you can continue to run process isolated because it's all your applications. In a multi-tenancy environment, you probably want to use hypervisor isolated because then neither the host or the containers can see each other.
Yeah. So now I see these base images, and I would now go out and see, okay, I want to have obviously my application in there. Would I now just go out and start up a container and install an application in there, or what would I do? Like, how would I do that?
Yeah, you want to take that?
Yeah, sure. So containers are built from this thing called a Docker file, and you can think about a Docker file as a recipe that has a instruction by instruction how to build that container image. So as we talked about a little bit earlier with Nano Server and Server Core, the Windows Container team publishes out these base images, and that is the ground zero building block that you would use if you want to build an application. So you're going to, in your Docker file, you're going to say, I want to choose that base image, and then you start layering on instruction by instruction, adding your process, adding some sort of configuration file that you need, installing .NET Framework 4.7.1. And then once you've built that Docker file, it's really just a text file. Yep. You use Docker, you say Docker build, and you point it at that file, and it will spit out this container image. And then that is, if we were to look at Docker images here on the left, it would show up under this list. So here's an example, actually. Server Core IIS is an image that the IIS team at Microsoft publishes that is based off of the Windows Server Core image that we publish.
Okay. So that's great too, because then I can obviously create my own container images, and we can talk a little bit about that in a bit. But I also have Microsoft and others creating already containers with the application in there, or the framework in there, or whatever I need. In that case, IIS.
Yep.
Yeah, so examples, we have images for the .NET Framework 4.7, .NET Core, IIS, WCF, ASP.NET, the list goes on. So, because we recognize that customers are going to be doing this, we want to help them avoid reinventing the wheel, so we'll just publish it for you.
Yeah. In our session tomorrow, we'll be showing a little bit more how to create your own Docker file for your application. How do you take your existing application and containerize that? Okay,
so make sure, so everyone basically who wants to know more about this and how to get started with that they come to your session tomorrow.
It's tomorrow at 2:15.
Okay, yeah. So let's say now we have that container, and it seems to be a very small thing, right? I have the base image, I have then my layers on top of it, as described. Now I want to move on. I don't want to run that obviously on my machine here, right? I want to test it here on my machine, but what can I basically go out and how do I get it to a server? Do I use a USB stick and copy it on it, or what am I going to do?
Yeah, so different than VMs, you don't pass the VHD or the VM image around. Ideally for containers, what you want to do is you want to store your container in a repository. People using container are probably familiar with the Docker Hub.
Yeah.
Docker Hub is Docker's repository for storing containers. Our containers, our images are actually stored in Docker Hub. Actually, they are available in the Docker Hub. They are stored in our own container registry.
Okay.
For containers that, for customers that want to create their own container registry for use, internal use, and so on, they can use Azure services like the Azure Container Registry. So they can spin up a store where they can publish their containers and then pull containers from.
Okay,
right.
So that's where I basically create my container, and then I publish it to the repository, store it in the cloud, and then basically pull it down everywhere. So I can easily share you the information where it's stored, and you can pull it down to your place.
That's correct, yes.
Awesome.
Let's see maybe an IIS image running here. Yep. So we can show some networking things. So as Craig mentioned, we have an IIS image. I can create a new container based on that container image. So if I run the Docker run, I'm going to use the -p to open ports. So in this case, the container is using a NAT network, yep. So it's a network address translation. So it's going to get an internal IP address, but then to get to the container from the external network, you access the IP of the host, you map a port from the host to the port of the container. So what I'm going to do here is I'm going to map the port 80 from the host to the port 80 of the container. I'm going to use the -d to say it's detached, so it's going to run in the background, just like a regular virtual machine, but in this case we're not accessing the container just like Craig did.
Okay.
I'm going to name my container, call it test container. You did not use this name, right?
I did not use that name.
And then I'm going to use this image over here called IIS. I'm going to copy here. And then I'm going to use, where's the tag over here? So it's the LTSC 2019. And there you go. In just a second, it should be up and running. So if I want to use a Docker PS, which is the command that shows me what are the commands that are running here, the containers that are running here, we have the first one. Docker gives you a funny name, and we have the test container because I gave a proper name for this container. Now, in order to test this, let's go ahead and get the IP address of this host. And let's see if everything goes right. they should have an IIS,
Yeah.
just like a regular virtual machine, but in this case, it's in a container.
Yeah.
So you saw we actually spun up the container really fast compared to a virtual machine.
So hammering on that point, like he just brought up an instance of IIS without having to configure the actual host.
Yeah.
In a matter of 2 seconds, that container
Yeah.
booted is just phenomenal.
Yeah, I was just thinking if I would do that in a with a virtual machine until I like started the virtual machine and attached the ISO, you're probably already done spinning that
Exactly.
IIS image up. No, that's fantastic. And I saw you running that now in a virtual machine running in Azure, right? You're running on top of a virtual machine running in Azure. I obviously can also run it in a virtual machine in my data center if I want to. But what if I don't want to care about the virtual machine? Is there also a Azure service or something where I can put it into?
Yeah, the first Azure service is ACI, so the Azure Container Instance, where you can spin up a container. You give the container to Azure, Azure will run the container for you, and that's it.
Yeah.
Now, the next step is I have a complex application. It's a multi-tier application. The tiers will scale up and down separately and independently. I have to deal with load balancing, failover, update domain, upgrade domain, all those regular operations for the applications. How do I orchestrate my multiple container application? And that's where Kubernetes comes in. And at Microsoft, we have the Azure Kubernetes Service, which is another option for customers who want to not have to deal with all the Kubernetes infrastructure. They can use the managed Kubernetes service from Microsoft.
Okay, that's awesome. Yeah, that was one of the next point I have. I mean, like putting up one container, that's fantastic, right? But usually our applications are like multiple servers, multiple processes, multiple applications with a back end and like a front end and some application systems. So how would I basically do that now? I have those different container images. Is there a way to like describe that application, or how would I do that?
Yep.
Yeah, sure. So actually, you're hitting on a really good point, which is that in reality, for production applications, it's not just going to be a single container. You have multiple tiers usually. And so what you want to do is containerize those individual tiers, and you're going to use a thing called an orchestrator to describe that deployment. And so Kubernetes has emerged as the de facto orchestrator, and Windows containers, as of Kubernetes version 1.14, is stable. So Kubernetes now supports Windows containers.
Awesome, awesome. I see we got a questions from the audience. And by the way, if you have questions, go to aka.ms/ignite. There you can basically ask us questions and it will show up here, and I can ask these gentlemen some interesting questions about Windows containers. So Steve has a question, and he asks like 5 GB for a container image is huge compared to other containers that I manage. Is there a way to make it smaller?
Yeah, the team has been working on that. Craig, you want to?
Yeah, so I think the first thing that you got to keep in mind is you want to pick, Steve, the image that's going to make sense for you.
Yep.
So we have options with NanoServer being really small at 100 megabytes for starters, and then Server Core is at 1 gig. But when you do layer on things like the .NET framework, it does start to grow. And so, Steve, I think the key thing is try and pick the base image that does work for you. Unfortunately, with Server Core, it's you're kind of stuck with what we give you right now. So,
but the good thing is you mentioned that layering thing. So if I have now multiple containers based on the same base image, it sounds funny, but then I don't need to store 5 gigs or whatever the size of the base container image is all the time. It's just the layers on top, if I understand that correctly. Is that correct?
Yeah. No. Yeah. Go ahead.
Yeah, sure. So another great property of containers is that they are layered, and so you do avoid the duplication of layers. Where, say, so Vinicius has built an IIS application. Say I come along and I use pretty much the same layers that he used, except I add an additional layer to some sort of file or something. Yeah. Those layers are still stored on your host without duplicating the unnecessary layers. So it only adds that little layer of my 1 megabyte edition or something like that.
Okay, that's awesome.
And even the pull will be only for the layers that you actually need. We won't pull all the other layers.
Yeah, that don't exist already on your machine.
Okay. So that's awesome. That sounds like good.
The good news is that with these container images, after you pull down that image onto, say, a VM in Azure, you only have to pay for that pull time once. Okay. And every time after you fire up containers, it's using those cached layers.
Okay. So that's what I like about the container stuff. And I first saw it. There's a lot of magic behind the scenes, like again, like duplication, like the processes, memory sharing, storage sharing with the layers and things like that. That makes it super fast and efficient in that case.
Yeah.
one thing, though, to get back to Steve's question, I don't want to paint it all as roses and rainbows. We are looking for feedback on what components we should be removing from these container images that are unneeded. So, Steve, if you have feedback on things that you don't need, we're happy to trim it out, and we're always looking for ways to do that. So please, community, give us feedback on things that we don't need to be in containers and we can remove.
Yeah. Okay, so that's awesome. So the next thing I got a lot is if I speak to people like, containers are kind of like that developer thing, and like I'm an IT pro person, what do I actually do with containers? And I realized with our conversation that there is things we need to do, right? There is some operations involved. It's not just, I'm like a developer, I create a container and then that's it.
Yeah, absolutely. In fact, I mean, it's extremely important that operations teams and development teams work together. We know for a fact that when they work together, they are more productive and things go better when they work together. However, once the container is deployed, yeah, you have to manage the container, you have to manage the life cycle of the host, and so on and so on. And we've been working hard into trying to enable the IT pro out there and the ops folks to be able to use containers more easily. One of the things we did is Windows Admin Center. So what we're showing here is the actual interface of Windows Admin Center. You're probably familiar with this. It's the regular deployment of Windows Admin Center. We are targeting the same node that we just used. And as you can see, we have an extension here called containers. So when I click this extension, basically what it says is, well, this is a container host, and it's running, this is the summary of your host. It's running 3 containers, you have this many images, you have these networks available for the containers to use, and the other thing is you can also map volumes into those containers for getting persistent storage.
Okay.
Right? When you have the containers running, if you click the tab for containers, and that's the part that I like for an operations person, you want to be able to troubleshoot the application that is actually running inside of your container, right? You want to get the logs, you want to see what's going on. So one of the ways you do that is when you select one of the containers, you have some details here in terms of how much CPU, how much memory, networking this container is using. But also you get additional details on the deployment of the container, like what is the image that you were running, and so on. But then if you click events, if you are familiar with Event Viewer, or using events inside of Windows Admin Center, this is going to load in a few seconds. Yep. You get pretty much the same logs that you would in a regular Windows machine. So if I select, for example, the application logs here, I have all the application logs from this container, and I can select the specific log and see more details about each of the things that are going on inside the container.
Yeah. Well, that's awesome. That's basically giving me a web-based view on what's going on with my containers. The things you just showed me with Docker and the CLI, yep. I can basically get that view directly in there. And the log thing, I'm just stunned right now because I was talking to a couple of people. They tried to troubleshoot containers, yep. right? And they had those weird tools which they needed to use, and it was very tough to basically get out. But that seems to make it very, very simple. Yeah, for a Windows admin, this is the regular way they are used to operate with virtual machines and regular deployments of Windows. So this is make it really easy. For people that are already familiar with containers and are using Docker, there's the option for using Docker logs. And this week, we just released an open source tool for getting logs out of the container in the same format that we have for Linux containers. So it's really cool to see this coming together, not only for Windows administrators, but also for folks that are out there already using Docker to be able to use the same tools. Okay. I just became a huge fan of Windows containers. Yes. So how do I get started? What's my next step? Where do I go to learn more? I'm going to pass that on to...
You have dark mode docs. Right. This is awesome.
Yep.
Actually... so this is our container documentation, and I think I'm noticing a bug right now because it looks like we've
just reload the page. I load this before we got on.
There we go. Okay, there's the tab view. So this is our container docs, and we wanted to make this the one-stop shop for all your container needs, whether it's conceptual knowledge, tutorials, how to get started. So, looking at this page, you're asking how you get started. Well, you go right to this Get Started card, you click here, and you're on your way to setting up your environment. You choose whether you're running on Windows Server or Windows 10 Pro and Enterprise, and you follow the prompt. So what's going to happen is you're going to install Docker, like you saw the tool that we were using earlier, and really you're going to be up and on your way. It takes a matter of a couple minutes to get your machine configured. Yeah.
Oh, that's awesome. Now, I like that you have that great docs where I can just go and try things out. One question, I hate to bring that up, but I get that a lot, is now, okay, we have all those containers, and how do I license these? Like, you're showing me a way now to basically replace my virtual machines and isolate my applications, which I've done with virtual machines. So what does this thing cost? Like, how do I license this?
The good news is it's all part of the Windows Server license. So if you have a Windows Server license, the standard version you can use for the process isolated unlimited, but then for the hypervisor isolated 2 containers, if you have data center, is unlimited for both.
Okay, okay, that's awesome. No, that's great. I learned a lot. You have your session tomorrow, if I'm correct, right?
That's correct. We'll be showing actually how you take a Windows Server 2008 R2, ASP.NET 3.5 application, and containerize for Windows Server 2019.
Oh.
So it's pretty cool.
Okay, that's awesome. So thank you very much for having you.
Thank you.
Hope everyone goes to your session, and we are going now back to the breakout session of Haley and Jeff, which will talk about bringing hybrid services from Windows Admin Center. See you in a bit.